Hi, teacher and classmates. In this class, I talk about introduction to stress, normal stress, shear stress, super stresses, application of stress analysis, and the conclusions. Okay, first, the introduction to stress. Stress is a physical quantity that describes the internal force acting on a material body. It's defined as the force per unit area and is a measure in units of pressure. There are three types of stress: normal stress, shear stress, and super stresses. Each type of stress has its own unique characteristics and effects on materials and different materials. Normal stress. Normal stress is the stress that act perpendicular to the surface of a material body. It is also known as compressive of tensile stress depending of of, of whether it's pushing or pulling the material. Normal stresses can be used as the formation or failure of a material depending on its magnitude and the material's strength. For example, excessive tensile stress can cause a material wire to snaps. Shear stress is a stress that acts parallel to the surface of a material body. It tends to cause deformation or failure by sliding one part of the materials past another. Shear stress is important in engineering applications such as cutting, drilling, and bending. Excessive shear stress can use a material to fracture or break apart. Um, Finally, super stresses. Super stresses are the stresses that act on a material due to external support or constraints. They can be either normal or shear stress depending on the orientation of the support. Super stresses are important in structural design as they determine the load carrying capacity of a structure. Proper support design can prevent catastrophic, failure of a structure. Okay, now I talk about application of stress analysis. Stress analysis is an important tool in engineering design as it allows engineers to predict how materials will behave under different loading conditions. Stress analysis is used in fields including aerospace, civil, mechanical, and materials of engineering. It's used to design structures, machines, and components that can withstand the stresses they will encounter in uses. In conclusions, understanding the different types of stress and their effects on materials is crucial for engineers and designers. By analyzing stresses in materials, engineering can design structures and components that are safe, reliable, and efficient. Thanks, teacher.